So now I've moved my service hose over to my nitrogen regulator. Now we're going to do any repairs that we have to do. Brazing, mechanical, flare nuts, anything like that. While we're doing that, I don't want to just have air coming into my system. So I'm going to set up to have nitrogen purging. It'll be at a lower pressure for brazing. And then we'll raise that back up for our full pressure test. So to start, nitrogen regulator should be all the way out. Turn my cylinder on. Once your cylinder's on, you can spin this in until you reach the correct pressure. There's other tools that you can use as well to get your brazing pressure, which is very low, like 3 to 5 cubic feet per hour of nitrogen, or purging, a little bit higher, like 10 to 30 cubic feet per hour purging. Once we've done that, once we've set all that up, we can slowly start introducing it into our system. I'm going to crack that open, crack these open. I want to make sure that there's a way for that nitrogen to enter the system, go throughout, clean everything, flush everything, all the way back to the other side. So to do that, I'm going to keep my low pressure side closed. So it's not going to get any pressure back from my nitrogen cylinder directly. It'll only get pressure once it goes through the whole system all the way through. So crack off that pressure. I'll open again my service valves, mid-seat, and mid-seat. Now the pressure on my high side will start to rise. It's a bit high, so I'll turn that down. Pressure on my high side is rising. That's pushing through my filter dryer, my sight glass, the solenoid valve with the magnet on it.
Why would you want to avoid high pressure during your purge?
If you have too much high pressure during a purge, it can help any moistures crystallize, basically turn to ice, or condense into the oil, which will take longer than to evacuate after. So to make sure that you're the fastest evacuation possible, low pressure on the purge, continuous flow. In this case, I have pressure come to here. My solenoid magnet is on, so it's definitely getting past here, but it's not coming back to this side. The only thing that could be in the way is the EEV. Hard shutdown TXVs and EEVs sometimes close up entirely when they shut off. What that means is that once they've shut off entirely, you're not letting any gas through to the other side. I won't be able to purge all the way through this way unless I grab an EEV magnet for this system to manually open that EEV.
Would that mean you wouldn't be able to fully recover all the refrigerant?
No. We can still fully recover all the refrigerant because we're pulling from both sides of that EEV as a whole. It does take a bit longer, but that's the only downside. Now, for nitrogen purging, we're going to have the same problem though. We're only pushing into the liquid side, nothing's coming out of the vapor. So, we're going to have to purge into the vapor, put pressure on both sides, do our repairs, wherever they may be, and then shut them back down after. So again, for purging is going to clear out all of the lines. You want to make sure that you can open all the valves if possible to do that. If you can't, if there's no way you can possibly get that EEV open it up and have a full cycle through, what you're going to do is fill both sides, kind of like rinsing out a tub. You're going to fill up both sides and let it drain out. And fill up both sides again, let it drain out again. So we're going to do that just by closing off my service hose, cracking these two both off, releasing all that pressure, and then do the same thing again. So we've filled up our system with dry nitrogen. That dry nitrogen is real thirsty, so it's picked up any moisture. It's picked up any junk left in the system. And then we're draining it all out, so it carries it out with it. And then we can set up again, very low pressure, put a tiny bit of nitrogen in there, let that nitrogen drink up any of the moisture that's left in that system, and then drain it out again. All right. At this point, we have finished our repair while purging, whether it be mechanical, flare nuts, brazing, any other repairs that we've done. We get to the point where now we need to do a pressure test. Pressure test is required to make sure that it can handle the amount of refrigerant pressure that it's going to be facing. There is two sides to every system, a high pressure side and a low pressure side. That means that there will be a design spec for it to go to. If I check the manufacturer's labels up here on my condensing unit, I have a high side pressure rating of 500 psig. But over here right next to it, it has a low side pressure rating of 180 psig. Some people will just say go to the 500. That is incorrect. Anything in the low side of your system could be damaged by that high pressure. It's not designed to handle that. More than that, other components in the system that may not be part of this main condenser, like the EEV, the evaporator, or any other controls, like our pressure control right here, may not be able to handle that pressure, and you will damage those if you pressure test to a very high amount.
Have you found scenarios where you would damage those components even at low pressure?
No. Unless there's something faulty, that low pressure should be good. If there's ever a question of how much to pressure test to, if you can't find enough information, you'll check your B52 code book for the refrigerant that this system is designed for, and there will be a minimum design pressure on the low side and the high side. That's table 4 of the B52 code book. Now, for this one, I've checked through everything. I know that 180 is good for our system. I've checked my controls, my evaporator, my EEV, checked the documents over. 180 is good. So I'm going to set up for my pressure test now. Have my tank on. I'm going to set this low. Fill up both sides equally since I can't go through my EEV right now. I'm going to slowly turn up my nitrogen pressure to reach exactly 180 psi on my gauges. Alright, now that I've reached that, I'm going to close that valve all the way off, close these two valves all the way off. At this point, I also like to turn my nitrogen off and relieve any excess pressure on this side. Now I have no pressure in my nitrogen hose. Even if my gauges are leaking a little bit, it won't give me a false positive on my pressure test. I like to take a picture of my gauges. Do that. Take a picture. I have minimum 1/2 hour to do my pressure test. The minimum pressure test is half an hour.
Would you also record the weather at the time, depending on if you're inside or outside?
Depending on the environment, the system type, and the length of your pressure test, you may want to check temperatures. For something this small, running only a half hour, I don't need to do that. For a large system where we're maybe going a 24-hour test or longer, that information will become important. Since as the temperature rises or drops, the pressure inside there will. Well, this is going on my half-hour nitrogen pressure test. I'm going to go set up some other tools. Anything I can do to clean up, get organized, set up things properly, I want to take care of all of that now. I have half an hour to wait. So for me, I'm going to grab my vacuum pump. This vacuum pump will work, has a couple things, or doesn't have a couple things that you may want on a vacuum pump for yourself. This vacuum pump has no ballast, which means the oil will get dirty faster. This vacuum pump also does not have a blank off valve, which means I can't isolate the vacuum pump on its own. If possible, you would want a vacuum pump with those things on there so that you can do an easier, safer job. Would somebody be mind actually just go and grabbing a different pump? So this is one of the cheaper vacuum pumps. It doesn't have those features. I don't like this vacuum pump. So I'm not gonna use this one.